Let's start with part 4. This is the advanced section of TensorFlow, where we'll be covering deploying TensorFlow models, distributed TensorFlow, and understanding TensorFlow extended TFX. So in the deploying TensorFlow models, let's go over those first, where we'll be saving and loading models, TensorFlow serving for model deployment, and TensorFlow Lite for mobile and embedded devices. Let's kick off with saving and loading models. Now, deploying TensorFlow models involves several steps, including saving trained models to disk and loading them for inference in production environments. Let's deep dive into the process of saving and loading TensorFlow models. The first step is saving models. After training a TensorFlow model, you'll want to save its architecture, weights, and optimizer state to disk for future use. TensorFlow provides multiple ways to save models. First one, save the entire model. You can save the entire model, including its architecture, weights, and optimizer state in a single file using the save method. You can just say model.save and give a name and save it as .h5 file. Save a model architecture and weights separately. Alternatively, you can save the model architecture to a JSON or YAML file and save the weights to separate HDF5 files. You can do that by saying that first save model architecture to JSON file using with open model.js JSON and then w as write as JSON file and JSON file.write function and pass model to JSON function. Next, save model weights to HDF5 file. You can say model.save weights and give it a file name and give the extension h5. Next step is loading models. Once you've saved a TensorFlow model, you can load it back into memory for inference or further training. TensorFlow provides methods to load models saved in different formats. So load entire model. To load an entire model saved in a single HDF5 file, use the load model function. So whatever we did in the previous case for saving, we can load it by using from TensorFlow.keras models, import the load model module, and then you can call that load model function and just pass the HDF5 file that you have given. Next is load model architecture and weight separately. The ones that we saved separately, to load the model architecture from a JSON or YAML file, which we did in the previous step, and load the weights from a separate HDF5 file, use the following methods. So here, if you see, what I do is I'm importing model from JSON and then loading model architecture from the JSON file by calling with open function, where I am passing the model.json and I'm saying read a JSON file. Load the model, create a variable for loading the model and call the JSON underscore file.read function, and the loaded model is loaded into model from JSON and pass the load model underscore JSON here. Next, if you want to load the weights from HDF5 file, all you do is like loaded model.load weights function and pass model weighted.h5 file. Model compatibility. When saving and loading TensorFlow models, ensure that you're using compatible versions of TensorFlow and Keras. Models saved with one version may not be compatible with other versions due to changes in the underlying API. So be careful about that if something is messed up because of that. Next step is model serialization options, where depending on your deployment environment and requirements, you may choose to serialize your TensorFlow models in a different format, such as HDF5, JSON, or protocol buffers, protobuf. Evaluate the pros and cons of each format based on factors like file size, interoperability, and ease of use. Saving and loading TensorFlow models is a crucial step in deploying machine learning models to production environments. By following the appropriate methods for saving and loading models, you can ensure seamless integration of your trained models into production pipelines and application. Consider factors like compatibility, serialization options, and deployment requirements when choosing the best approach for saving and loading TensorFlow models in your deployment workflow.